Alright, so in today's video, we're going to look at solutions to a polynomial. Okay, so the solutions to a polynomial, you can have real, you can have imaginary, and you can have rational and irrational, okay, which is part of the real. Different solutions. So I'm going to show you how to look at Desmos to get all of your real solutions, and then I'm going to tell you how to find out how many imaginary. We're not going to find the imaginary, we're just going to state how many there are, okay? So how does the degree of a polynomial relate to the number of x-intercepts? Well, the number of x-intercepts, which we also know are solutions and zeros and factors, okay? So the number of x-intercepts to a polynomial function is equal to the degree, which we're going to change x-intercepts to solutions because we're talking about solving. Okay, so the number of solutions to a polynomial function is equal to the degree of the polynomial. Okay, all right, so whoops, there we go. Okay, this theorem can make it possible to know the number and type of zeros in a given function, which can be helpful in finding zeros of a polynomial. So I want to determine the number of zeros. It didn't tell me to classify. I just want to know how many there are. Well, you find the degree of your function. The degree of your function is your highest exponent in standard form, which is what you're going to be getting. Okay, I'm not going to give it to you in factored form. All right, so your degree is your highest exponent. So in A, I look, my highest exponent is 3. So we will say there are 3 solutions. Okay. B, find your highest exponent. Well, pretty dramatic here. My highest exponent is 13. So there are 13 solutions. Okay? Now, only real zeros can be found using a calculator. Complex zeros must be found by hand. But we're not going to be finding what they are. We're just going to be stating how many there are. Okay? So, you can always use this trick to figure out how many zeros you should expect from a polynomial. Okay? So, now, let's solve. So when I mean solve, we're just going to be stating stuff, okay? All right, so I want to find all real solutions. Then I want to state how many complex imaginary solutions there are. Now, sometimes you won't have any imaginary and complex, so we would just say 0 complex and 0 imaginary, okay? So to find all real solutions, we're going to use Desmos because a solution is where the graph crosses the x-axis. So we're going to go to Desmos, okay? And we're going to type in our equation. Y equals x cubed plus 12x squared plus x minus 1. Okay? So if you look, sometimes you got to zoom out, okay? So if you look, it crossed. So one solution is going to be, it's just your x value, because remember, solution is like x equals. So one solution is 0.248. So we'll say x equals 0.248, because remember, how many total, I should have said this, but how many total solutions should we have for this one? We should have a total of 3, okay? So keep that in mind. So that's one solution. We go back. We have another solution at negative 0.339. So x equals negative 0.339. And then we have that other guy over here, okay? And that is negative 11.909. So, do we have any complex zeros here? Is there anything we're missing? We said we need to have a total of 3 zeros. How many zeros do we have? We have 3, so there are no complex zeros. Because we got all our zeros from the graph, that means there are no complex zeros left. Okay? All right, let's do another one. All right, so I want to do the same thing here in number 2. I want to state all real zeros and then tell me if there are any complex imaginary solutions, okay? So first, we need to find the degree. So the degree of this function is 4. So that means I should have a total of 4 solutions, okay? And that includes the real, the complex. That is in total, okay? That is all your solutions. So you should have no more than 4 solutions for this polynomial, okay? So first we go to Desmos and we find our real, okay? So we're going to go to Desmos, all right? Exit this one out. It's going to be y equals x to the fourth plus 2x cubed plus 2x cubed minus 6x squared minus 2. Okay? All right. So I should have 4 solutions here. So let's zoom out and see if we got any stragglers. We don't. All right. So if you look, I only have 2 x-intercepts. So I only have 2 real solutions here. So one real solution is going to be 1.764. So x equals 1.764. That's 1. Another one is going to be negative 3.674. I done forgot what I said. Negative 3.674. 674. Alright. Well, that's only 2. I said I'm supposed to have 4. But I only have 2. So that means your leftovers are your complex solutions. So this means that there are 2 complex solutions. Okay? So I have 2 real solutions, and then I have 2 complex solutions that they're there. We're not going to find them, but they're there. Okay? Alright? Alright, let's do number. Okay, so I want to find out how many zeros I'm supposed to have, then state the real, and then tell me how many complex are left over, okay? So if you look, my degree is the highest exponent, and my degree is 3. So that means I should have a total of 3 zeros, solutions, okay? So we're going to go to Desmos, and we're going to see how many we have, and then whatever's left over is complex, okay? All right, so we go to Desmos. We're going to type it in, okay? We got y equals x cubed minus 7x squared plus 2x plus 40. Okay? So y equals. All right. So, well, this one crosses 3 times, and that's all our solution, isn't it? So one solution is going to be 5. Another one's going to be 4. So it's 5, 4, and negative 2. So x equals 5, 4, and negative 2. And that's 3 zeros, so guess what? There are no complex solutions. Okay? All right, let's do another one. All right, so we need to find the total number we're supposed to have. Well, the highest exponent here is 4, so I should have a total of 4 solutions. Okay? So we go to Desmos to see how many of those solutions are real. Okay? So when we go to Desmos, I'm going to type it in. Y equals x to the 4th minus 5x cubed minus 11x squared plus 25x plus 30. Plus 30. Okay? Alright, so if you look, it crosses 4 times. So one solution is negative 1, another one is 6. So I have x equals negative 1, x equals 6. Another one is 2.236. 2.236. And then the last one we saw was negative 2.236. So, do I have any complex solutions here? No, that is all 4 of my solutions, which I said is what I should have. So, there are no complex here either. Okay? No complex solutions. All right, let's do another one. All right, so let's find this one. Okay, so my degree is 4, so I should have a total of 4 zeros. Okay? All right, let's see which ones are real. Let's see how many real we have, and then let's see whatever's left over is going to be your imaginary. Okay? So we go to Desmos, and we're going to type it in. Okay? If I can get it to exit. There we go. All right, so y equals x to the 4th minus 3x cubed plus 21x squared minus 75x and then minus 100. Okay? Alright, so let's zoom out just to make sure. Well, that's it. There's only 2 real solutions. Okay, so 1 is 4 and 1 is negative 1. So x equals 4, x equals negative 1. Well, that's only 2 of the 4. So that means that there are 2 complex solutions. So we have 2 real, and then we would have 2 complex. Okay? All right. So I don't know if you noticed this, but when we were doing the imaginary, which is complex solutions, you always noticed there was an even amount of them. Okay? That's a reason. Okay? There are 2 theorems that we haven't gone over yet, and it's the irrational root theorem and the imaginary root theorem. So the irrational root theorem states that if a plus the square root of b is a root, then the conjugate a minus the square root of b is also a root. Same thing goes for the imaginary root. If a plus bi is a root, then a minus bi is a root. All it means is you're changing that sign in front of the complex or irrational number. So you'll always have pairs of imaginary number. You'll never have 3 imaginary roots. You'll never have 7 imaginary roots. You'll only have like 6, 4. You should only ever have an even amount of imaginary roots. So this says to state the conjugate of the expression. Okay? So the conjugate just means you're changing that sign in front of the imaginary or irrational number. So if I want to state the conjugate of 3 minus 7i, it's going to be 3 plus the square root of 7. Number 2, 1 plus 2i. If 1 plus 2i is a solution, then 1 minus 2i is also a solution. If negative 12 minus 5i is a solution, then that means negative 12 plus 5i is a solution. Do you see how I didn't change 12's sign? It's only the sign in front of the imaginary or irrational number. Okay? 4. If negative square root of 15 is a solution, then positive square root of 15 is a solution. If pi times I is a solution, then negative pi I is a solution. Okay? So most of the time they're only going to tell you negative square root of 15 is a solution. You have to know that the square root of 15 is also a solution. Okay? All right, so that is it for today's lesson. All right, guys, let me know if you need anything else.